My name is Sun Kwok. I'm a chair professor of physics and dean of science at the University of Hong Kong. For the last 30 years, I've been studying the death process of stars. Stars don't live forever. Like our sun, for example, is about 4.5 billion years old, and it has another probably 5.5 billion years to live. After that time, then it will go through a death process. But what happens after that is really not that well known. What we were studying and finding out is that stars like our sun, just before they die, they will go through a very spectacular firework display. So they become all of a sudden extremely energetic. They create something what we call a planetary nebulae. Behind me are two examples of planetary nebulae. These are objects that our sun will become in another 5 billion years or so. They have colors of red and green because they are radiations coming from different atoms inside the nebulae. What we're trying to do in our research is to understand the process of stellar metamorphosis, which is how does an ordinary star, which is round in shape, can become such a wonderful, beautiful, butterfly-shaped object. We make proposals to the space agencies and get observing time on the space-based telescopes. Afterwards, we also try to carry out follow-up observations from ground-based telescopes. We do most of our ground-based observations in the high mountain of Hawaii Island. They have a mountain called Mauna Kea, which is at 4,200 meters above sea level. We do a lot of our spectroscopic observations in the infrared, and there's really no other better place on the surface of the Earth to do such observations. Every time I go there, I feel like going on a pilgrimage, because going up the mountain and looking at the wonderful sky and being able to find the secrets of the universe is one of the pleasures of being an astronomer. After we make the observations, then the data was sent back to the telescopes, to the ground stations, and back to us for data analysis. What we have discovered is that when a star in the very last stage of their lives, they are able to produce very complex organics. Not only they are able to make these things, they are also ejecting them in the form of a stellar wind and send them all across the Milky Way galaxy.
我们现在正在寻找一些在星际里面的一些复杂分子，像碳六十这种。碳六十是一种碳的一种新的形态，它是由60个碳组成一个足球状状的一个分子。我们在得到的光谱上面找寻这些碳六十的一些信号。当我们看到碳六十的信号的时候，我们感到非常激动。
These discoveries of stellar organics is really a surprise to everyone. The International Astronomical Union has a commission called Bioastronomy. They also hold the first symposium in Hong Kong in 2008. The title of the conference is Organic Matter in Space. So this field of research is taken extremely seriously. I think this discovery illustrates the importance of interdisciplinary studies. And now we are seeing the development of new disciplines, for example, astrochemistry or astrobiology, meaning that we are not being bounded by knowledge or expertise in a single specific narrow areas. In order to understand how the universe works, what is the universe made of, we need a wide spread of knowledge among many different areas. One of the implications of this discovery is that all these organics could have been delivered to Earth during the beginning of the solar system. There is a very strong interest in the scientific community in trying to find out whether such organics play any role in the origin of life on Earth. If we benefited from external ingredients to get a life started on Earth, then it's quite possible that similar processes are also at work elsewhere in the Milky Way galaxy. We used to think that we are unique and different, but now the views have really changed. We believe that life, in fact, could be very common, and the next step for us is to find the actual examples of life existing first maybe in Mars, in other planetary satellites on either our solar system, but even further away.